Okay, number one, we are going to multiply these. So I'm going to begin by getting my fraction bars ready. And we have to factor all of these little parts. So the upper left is a dots problem. So that's going to factor to be x minus 7 and x plus 7. That way it makes 49. Lower left, I can divide those numbers by 2x. So that would leave me with 2x plus 3. Multiplying. Can't make a dot. Come on. Alright, upper right, we can factor out a 2x. That's going to leave 4x plus 5. And in the lower right, factor that trinomial to be two numbers that multiply to make 21, add up to 10. 7 and 3. Okay, now we start canceling out anything that we can. Looks like we can cancel out an x plus 7. Looks like we can cancel out these two x's. And that's all I'm seeing. So I believe my final answer is going to be, so you do one fraction bar and you just squish everything sort of back together. So I'm just going to take this x minus 7 and put it right beside 4x plus 5. Down on the bottom there's a 2x plus 3 and an x plus 3. Letter B, we are dividing. What you've got to remember is we keep the first fraction the same. We switch the sign from division to multiplication, and then we're going to flip that last fraction. So keep, switch, flip. So again, I'm going to turn that division sign into a multiply sign. Upper left, I can factor out a 3. Lower left, looking for two numbers that multiply to make negative 28, that add up to 7, or I'm sorry, add up to 3. That's going to be positive 7 and negative 4. Okay, so remember, these guys are flipping, so the x squared minus 9 is actually going to go on the bottom as x minus 3, x plus 3. It's a difference of two squares. Now the 4x minus 16 factors to be this up on top. And now I cross things out. So x plus 3 goes away. X minus 4 and x minus 4 goes away. And now I just multiply top times top, bottom times bottom. So again, what I've got up there is I've got a 3 up there and I've got a 4 up there. That's going to turn into a 12. On bottom, I have two pieces that I never did anything with, the x plus 7 and the x minus 3. So okay, that's the end of that. Alright, adding and subtracting. Number 2a is really not too bad. It's already got a common denominator. So I can pretty much just go straight to an answer here. X minus 6 on the bottom. And now I'm looking at the like terms up on top. So I'm seeing that 5x minus negative 3x. 5x minus negative 3x. That's going to make an 8x. Furthermore, I've got a 15 minus a positive 20, so 15 minus 20 is negative 5. That's my final answer right there. There's no simplifying that you can do there. That's done. Alright, so letter B I went ahead and rewrote to give myself some more room here, but The problem here is that the denominators are not the same, so that makes the problem significantly more challenging. So first we need to rewrite our fractions with common denominators, and what we're going to do is we're just going to basically take this 8x and this x plus 1, and we're going to combine those together to make a single denominator. So it's going to look like this. I'm just going to take the 8x, I'm going to stick parentheses around the x plus 1, and that's going to be my common denominator. It's just like in elementary school, you multiply the denominators together to get a common denominator. Let's see. Now if you think about it, what I had to do was I had to give this fraction an x plus 1 on the bottom. In order to justify doing that, I have to do that on top and bottom. So there's me doing that. And then this thing needed an 8x out in front, so I have to basically give them that. Now that I have that, I'm doing the distributive property. 7x times x would be 7x squared. 7x times 1 is positive 7x. Over on this right hand side, I got 8x times 2x. That's 16x squared. And 8x times negative 3 is negative 24x. So the final answer here is going to be a single fraction with the common denominator of 8x times x plus 1. And I'm going to combine like terms across the top. So the 7x squared plus 16x squared is going to be, what is that, 23x squared. And then furthermore, I've got this 7x plus a negative 24x. 7 essentially minus 24. That's going to be negative 17. And that's my final answer. Done. Okay, letter C is a similar problem to letter B. So here we go. I need to create a common denominator, and that's just going to be those two denominators squished together. Technically, I'm multiplying them together. From there, if you look back at the original problem, this left-hand fraction did not have the x plus 5, so I have to put that on the top. So let's see. There was already an x plus 9 up there, and now I'm going to put an x plus 5 up there, because what you do to the bottom, you have to do to the top. Over on the right hand side, there's an x minus 4 up there, and it needs an x minus 3. Alright, now the top of both of these fractions has worked out to be pretty complicated. They're going to each require double distribution to get that done. So you might remember that's like doing x times x is x squared. X times 5 is going to be a 5x. 9 times x is a 9x. And finally 9 times 5 is 45. And that's still over my common denominator minus this whole other fraction here. The distribution up there, x times x is x squared. X times negative 3x, I'm sorry, that's negative 3x, negative 4x, and finally negative 4 times negative 3 is positive 12. Again, I still have the common denominator going. At this point, I'm going to try to get a final answer out of this. All these parentheses are the same thing. I just getting lazy. Okay, now looking across the top here, I got a lot of stuff going on, but notice that the minus sign, I'm going to highlight that minus sign right there. We are doing right now x squared minus x squared. Well, x squared minus x squared would cancel out, so that's kind of cool. That's at least gone. Now I've got several x terms. I got 5x, 9x, minus 3x, and minus 4x. Well, 5 plus 9 would be 14, and I'm going to take away a negative 3. Well, minus negative becomes plus, so 14 plus 3 is going to be 17, and then minus a negative 4 would be another plus 4, so 14 plus 3, and then plus 4. That's 21. Let's see. Furthermore, I've got a 45 and a minus 12. So 45 minus 12 is going to be 33. And that is my final answer right there. That was a tough one. Alright, so we've got some ACT problems down here. Answer 2 of the following ACT problems. Shall we work? So there we have an expression. Let's see. Very common question on the ACT. So this is just a double distribution problem, and they throw an extra letter in there just to make it that much more difficult. So let's see what we can do. First of all, first times first. 7 times 2 is 14. And since that's c and c, I'm going to say c squared. 7c times 1d would be 7cd. You just stick the letters right next to each other. Negative 2d times 2c would be minus 4. And then I'm going to do cd again. Order of the letters doesn't matter. And then negative 2 times 1 is negative 2. And since it's d and d, it's d squared. Notice that these middle two terms combine. 7 minus 4 is a 3cd. And now we can essentially see our answer is D. Number 4, that is just a subtraction problem. So we have like terms. We got this 6a minus 4a. So 6a minus 4a is 2a. I've got a 5b minus 4b. 5 minus 4 is a 1b. And 4 minus negative 2. Careful with that. 4 minus negative 2 is really 4 plus 2. That makes 6. See? And that answer is available as answer A. Okay, number 5. For the right triangle shown below, which of the following expressions is the value that's equal to the cosine of A? Well, you might remember from geometry, we learned about trigonometry, and what every student memorizes is SOHCAHTOA. And in this case, we only care about this one because that's cosine. That little guy stands for, it says that the cosine of an angle, it's a symbol for an angle. In this case, though, they want us to do cosine of A, so equals. Now, this A is referring to the adjacent side, and that's the hypotenuse. So looking at angle A, if that's angle A, then this is the opposite side, this is the adjacent side, the 9, and this is the hypotenuse over here as the 15. So this one's wanting adjacent over hypotenuse. So I'm going to say 9 over sorry, just screwed that up. Trying to erase here. Oh dear. It's not letting me erase, but cosine of A would be 9. Wait. Why did I think that was wrong? It wasn't wrong. I don't know what I was freaking out about. 9 over 15 is true. Now, it wants to know which of these answer choices is equal to that. Well, sine of A would be opposite over hypotenuse, so it would be 12 over 15, which is not the same fraction, so A is out. Sine of B would be from this guy's perspective. That sort of changes things. From this angle's perspective, this is actually the opposite side, and this is still the hypotenuse, and so it'd be 9 over 15, which is the same fraction that we have down here, which means B is the answer choice. And that is the answer.